inverse function, basically very basic, okay? Their domains and their ranges are switched, okay? For functions to be inverses of each other, one's domain is the other one's range. One's input is that one's output. And this one's input is that one's output. Okay, that's an inverse function. They have swapped domain and range. That's just an inverse function. Now, what we're going to do is we're going to test to see if functions are inverse, and then we're going to find the inverse of a function. I can't remember, but your book only does one of those ones. It doesn't do the other, but we need to do both. Leaving the book behind again. Yes, no, maybe. I think so. Alright, so this is f of x, and we want it, and g of x is the inverse of f of x, and g of x looks like this. The inputs became the output. The output became the input. Should switch. That is, right? One becomes the other. Now, think about this. Not all functions have inverse functions. What makes it a function? What determines if it's a function or not a function? For every input, there's only one output. All right. You think of a kind of function that may not have an inverse function. That every input has exactly one output, because what's going to happen is that output is like input. So are there any that maybe would repeat? Parabola. Yeah. Parabola is not going to have an inverse. Let's say f of x equals x squared. Alright, well, if I put in 1, if I put in 1, I get 1. If I put in 2, I get 4. If I put in 3, I get 9. What if I put in negative 1? You get 1. What if I put in negative 2? You get 4. What if I put in negative 3? Yeah, well, that's a function, right? But if I try to reverse those, if I try to make the inputs the outputs, I have 1, 1, 4, 2, 9, 1, negative 1, 4, negative 2, 9, negative 3. And we've just broken like that very first rule that you learn when you start learning about functions in Algebra 1. X is repeated. Okay? So this function does not have an inverse. Okay? If you graph a parabola, you graph y equals x squared. It passes the vertical line test, but it fails what we call horizontal line test. Okay? Because it fails that horizontal line test, that means it's not one-to-one. Okay? And only functions that are one-to-one functions that are one-to-one have an inverse. And one-to-one means that the x doesn't repeat and the y doesn't repeat. It passes a vertical line test and a horizontal line test. That's one-to-one. Another way you could look at it, a function has an inverse if it is always increasing or always decreasing. Always increasing or always decreasing doesn't mean that it's necessarily a straight line, okay? That's always increasing. That is not always increasing, okay? But if it's always increasing or always decreasing, if it's not going back and forth, then it's going to pass that horizontal line test. Right, so knowing what you know about even and odd functions, what kind of functions are going to have inverses? Odd, they're going to have to be odd. Because evens have matching in behavior, even degree functions have matching in behavior. They're going to fail that horizontal line test. Alright. I hear laughing. Somebody's located like some stuff all over. Okay. On that assignment, I can't remember, did you have to graph from the inverse? Is that one of your questions? Is there any graphing on that at all? There's graphing on the college algebra. Okay. The online one that you did like a year ago. Yeah, that was years ago. Okay. They're so close to being alike, I get them confused, the algebra and the pre-cal. It's just barely different. It would be much better if you did them. So if you remember which one you were using. It's really easy. Did it? Good. As long as it's good. It's really easy though to graph from the inverse because if you can just pick some points off of it, you just switch the x and y and that's turning points. So it is easy to graph. Now to verify inverses, we use composition of functions. inverses through composition of functions. So I think that f of x and g of x are inverses. I'm just not sure. No. In order to test to see if they're inverses of each other, you just compose them into each other. Find f of g of x and we find g of f of x. Relation to algebra 2. Alright, so 2 times 1 half x leaves you with just x, and 1 half times 2x leaves you with x. They are inverses because the answer for both is x. And that's a told you they're inverses. When you compose them and your answer is x, that tells you that they're inverses of each other. So you got okay. Okay, so f of x is 1/3 x plus 2. And I think that its inverse, that little negative one up here, that means the inverse of f of x, 3x minus 6. Use composition of functions to verify that those are, in fact, inverses of each other. I'm going to try to get it bright enough in here for you to write. So, I'm going to have 1/3 3x minus 6 plus 2. So it's going to be x minus 2 plus 2, which is x. So we get over there. We're going to have 3, 1/3 x plus 2 minus 6. It's going to be x plus 6 minus 6. X. Alright. And say check out. Alright. Alright, one more thing, and then I'll let you just concentrate on girls playing football. Finding the inverse. Finding the inverse. Finding the inverse is really easy. It's like 4 steps, okay? Change f of x to y. That's an easy step. I know I'm going to do that. Change, right? You would think that someone's going to be like, I thought you wanted to be cute. Alright, and then switch the x and the y. Solve for y. And then switch y with the inverse of the inverse of f of x. I don't have the words. I was like, how come you can't? No. Sounds like a personal song. No, right? Got it? Move it? No? I don't know. Please. Okay. And please. Units E and L. Alright, we 142 points right there. Not really, but still. Okay, what's next? Switch them. So now it's going to say x equals 3y plus 8. You're halfway there. And then what happens, boys and girls? Solve for y. Alright, so I'm going to subtract 8. You can't really subtract x minus 8 because they're not like terms. But we knew that already. And then I'm going to...
We're working on the problem.
Okay, so last thing we need to do is divide by 3. Now, you can leave it like this if you want. If you have to turn around and use this, you're going to want x over 3 minus 8/3 more than likely just because it's easier to work with. But if you had to graph this line, you're going to want it to look like that. So look like that. But that's not the last step. What's the last step? The inverse of f of x is x over 3 minus 8/3. That's your last final and now they can hit a little bit more. That's an easy one. Done with this? I thought I didn't know that. Right? Alright, so then change it to y equals 2x plus 1 over x. We'll switch roots. X equals 2y plus 1 over y. Alright, cross multiply. It's going to be very useful to you next year in calculus. Okay, when you start doing implicit differentiation. Gather your like terms on one side. Like I'm trying to isolate the y, so I'm going to put all the y's on one side. I have x, y, minus 2y equals 1. And that allows me to factor out a y. I know, it's like magic, right? Because then what can I do to isolate that y? Divide. Just divide by the x minus 2. And that's not going to hit because it's at the bottom of the screen. So y equals 1 over x minus 2. Keep that little trick in your back pocket for calculus next year because it's like the greatest thing in the world.